Welcome to the distance learning packet for IM2. Here we have week 4. This is page 3. All right. So the first problems 1 through 6 just asks you to do some unit conversions. Here I gave you a unit conversion chart. It's gonna be hard to do without a unit conversion chart. Okay. So here we have 7 yards and we want that into feet. So first of all, you always want to start with what you are given, which is 7 yards. Then you want to set up a fraction. So the fraction here is going to be something over something else. Okay. Here, the bottom number should be your yards and the top number is going to be your feet. Why is that? Because when you multiply, yards over yards will cancel out to make 1, right? That's the reason why you put yards on the bottom. Feet goes on top, all right? Because that is what you have. So yards and yards cancel out, giving you feet left, which is on top, which is what you want. The question is, what goes right here? How many yards and how many feet? We know that based on this unit conversion chart, or which is every unit conversion chart, yards and feet. 1 yard equals to 3 feet right there. So that's what we're going to write. It says 1 yard will go into 3 feet. You're going to multiply. Okay. When you multiply across, yard 7 times 3 is 21. There's really a number 1 here. 1 times 1 is just 1, but no one really writes it. And on top, you have feet left over. So 21 feet is your answer. Good. There's nothing left on the bottom. All right. If you did it differently, like if you did 7 yards over 1 times, and here you had feet over yards, if you multiply this, you see how you get yard times yard, which is yard squared? It wouldn't work well. Okay, so make sure that you have 1 on top and 1 on bottom so they cancel out. All right, next one, 5 feet squared is equal to inches squared. All right, so here we have, what do we want on bottom? We want feet, and on top is what we want, which is inches. All right, we're going to multiply, of course. How many feet and how many inches? We know that 1 foot is equal to 12 inches. So 12 inches, 1 foot. Multiply this across. 5 times 12 is 60 feet. And feet cancels out, leaving you with inches. So giving you 6 inches in the end. Okay, let's do this one. 1 mile equals to blank feet. So I'm going to set you up for this one, but you have to do this by yourself, okay? So 1 mile times blank, which is on bottom, which should be in miles, and on top should be feet. Okay? So look at what you have here. Ooh, do you even have that? Miles to feet. No, you have miles to yards. So what you need to do is you have to do this one more time. So you don't have a miles to feet. You have miles to yard. So yard, miles to yard. And that is 1 mile equals to 1,760 yards. But yards isn't what you want. So you need feet. So you have to do this again. Yard goes on bottom, and on top you want feet. Do we have that? Yes, we do. Yard, 1 yard. Do we have feet? Yes, we do. 1 yard equals to 3 feet. Now you have to just multiply it across. Okay. I'm just gonna do this for you because this was a long conversion. All right. So 1 times 1760 times 3. So 1 mile is equivalent to 5,280 feet. Giving you this some perspective, okay? An average football field is 100 yards, okay? So think about that. This is equivalent to a mile is around 18 football fields. Okay. All right. So let's do the next one. just unit converting. Centimeters to 100 meters into centimeters. Do we have a conversion for that? Meters and centimeters, yes we do. Okay, so let's do this one. You could do the, let me do this one for you. 100 meters. And on bottom, we're going to need meters. And on top, we want centimeters. Okay. All right. So meters and meters. And centimeters. 100 centimeters. So 100 centimeters will make 1 meter. Right? Is that what it says? 1 centimeter? Right. 100 centimeters. 1,000, no, 100, yeah, so this should be 100 centimeters is equal to 100 centimeters is equal to 1 meter. Yep. So multiply that across, you should get 100 times 100. So 1, 2, 3, 4. That is 10,000 centimeters. So 100 meters is equivalent to 10,000 centimeters. Next one. Let's do yards. So 300 feet. And you want this in yards, all right? You do have a conversion here, and it's very simple. What is your feet to yard? Okay, do that, and you should get your answer. Same thing here. 96 inches times feet is what you want. Inches is what you have. Okay, make sure you do that conversion. All right, you just need to plug in the numbers here. All right, but you are going to do numbers 5 and number 6 by yourself. Okay, if you need help, you are going to look at 1, 2, 3 for some assistance. Let's look at the next one. Graph each one of these quadratic functions. How do these functions compare? I'm just going to graph these and pull it into Desmos. I just finished graphing it on Desmos for you. The first one, f of x, is going to be in blue. The g of x, which is in red, and green is going to be the h of x. Okay, these are the 3 ones. The first one, they said, how do you compare each one of them together? Well, they're all the same shape. They are just shift from each other. So this is what I wrote. All the graphs have the same parent function. The graphs are different because they have different verticals and horizontal displacements. The first one, see, it says, how is g of x, h of x compared to f of x? F of x is the original one. If we take a look, the original one is blue. Okay. To get to red, they had a vertical shift down, and to get green, which is h of x, they went down. Then they went to the left. Okay, and you could look at the numerical values here. All right, let me just give you the vertices. For the first one is 0, 0. The second, the g of x is 0, negative 9, and this one, which is the h of x, the vertex is negative 2, negative 9. That's what I just displayed to you, that the vertex are how they're different. Last one, look back at the function and identify the x-intercepts. What are they? So the f of x, the x-intercepts, there's actually 2. It's they're double roots, okay, but one unique root. It's at 0, 0, 0. That is f of x. The g of x, which is red, the vertex for that one is 3 and negative 3. Then the next one, for h of x, it is 1 and negative 5. I just pasted it and copy and paste the graph here to make sure it looks like it. Then I could just write here. They said f of x, which is, I made it blue. And the x-intercepts are just going to be at 0, 0. The red, which is my g of x, is going to be at negative 3 comma 0 and 3 comma 0. Then my h of x is at negative 5 comma 0 and 1 comma 0. What are the coordinates of the point corresponding to the x-intercept and g of x in each other's function? How do they coordinates compare to each other? G of x coordinates to the x-intercept and g of x in each other's function. So, okay. So, if you look at this, you notice how they're apart here by a unit of 6. Okay. So if here is also different by a unit of 6. So from here to here, the distance here, it's 6. From negative 3 comma 0 to 3 comma 0, it's still 6. Same thing here, negative 5, 0, all the way to 1 comma 0. That's still a unit of 6. Looking back at the function, identify the x-intercept. What are the coordinates of the point corresponding in x and g of x in each other's function? How do they compare? Yeah, there you go. They have the same distance, but they're just shifted from each other. Here, they're just shifted 2 to the left, and it is because of this minus 2. So you can write that. There you go. So g of x has a vertical shift down of 9 units. That is caused by that negative 9 up here. Then h of x has a vertical shift down by negative 9, but also going a horizontal shift left by 2. There you go. Those are all your answers for page 3.